Hello, my name is Preston Zen and I'm with Kaizen Labs. So I'll be going over the proposal here for a UAV motor production line. So here's the contact info there. So, okay, basic intro. Kaizen Labs is a US based originally research and development lab. I went out to Ukraine during the start of the war, specifically focusing on UAV and drone related production. Uh, when I went out there, I was running point and I was helping out with setting up productions of just drones with the major components, whether that be the frames, the PCB boards, ESCs, cameras, and motors. And then in Kiev now, we're running one of the production lines for motors with Drone Space Labs. And our partners in China have run a handful of active motor production facilities and assembly lines out in Ukraine as well. And I also go in between China for that. So basically, the introduction here is that we have partners in Asia that do stator stamping, lamination, epoxy powder, everything to be able to make the stator cores, that main piece that you have to wind the copper wires on to make the motors. And then, of course, we source the magnets and everything else that's needed to make it be able to spin very quickly once an with the electromagnetic balanced positioning of the magnets, and then once you run a current through the wound cables, then it makes it spin. So our partners have been in motor manufacturing for over 20 years. Actually, one of the motor engineers is an ex-DJI engineer that produced motors with DJI for quite some time, for over 10 years with DJI, and is one of the consultants as well, which is one of our partners. They do motor design, manufacturing, and so we've established a lot of relations with them, especially throughout the last few years. Have all the equipment, all the products, all the components, all in one place. So they've built out motors for DJI with the experience, as well as T Motor and Emax, and the hardware through the partner network is also the same equipment that DJI, Emax, and the other major brands use as well. Everything from the copper wiring, magnets with high temperature resistance, the CNC parts, everything is all within the network. As Asia, specifically China, has one of the most refined motor manufacturing processes in the world, and so that community is quite networked. Machinery, so there's a good amount of machinery being done. So aside from just making the motors themselves in Asia and then bring them over in either custom or wholesale, the other option is to actually bring the machinery themselves. So the large machines that can wind the motors, mainly to wind the copper wire onto the stator cores, they have anywhere from 2 to 4 stations, and they can do a good amount of production of the winding. And so there, if you have a ton in series, there's entire assembly lines that can produce essentially 240 pieces a minute if you have multiple machines. But one machine can wind one motor stator core in 1 minute, and if there are 2 or 4 stations, then you can do about 2 or 4 of them per minute. So these ones are the 4 stations you can see here. It's kind of hard to tell, but there's 4 positions. That means it can wind 4 motors a minute, which is basically enough for one drone. And so if one of these systems is acquired, then there is on-site training. You can send some engineers out to the Guangdong province out in China around Shenzhen, and you'll be able to get hands-on training and whatnot with that. So the machinery, aside from the winding aspect of the motors, there's going to be the stator stamping, which is actually creating the stator core, which creates the base body to be able to run the motors themselves. You can't build a motor without a stator core because you need to be really strong so that you can wind the copper wires on them. Now, one of the top motors that are used in Ukraine and other kind of UAV and FPV scenarios is the 2807. That's the kV value, and that's basically the model. And so it's for 5 or 7 inch FPVs, and this is what the stator core looks like for a 2807. This is the piece that needs to be stamped out and epoxied together. So here's some of the specs on that, the tolerances, and here are a lot of the stator pieces that are stamped out. I believe that these are stacks of them stamped out, and then they get cut after they get epoxied together. Now these the machinery can do things up to 2807 and down, and there's other machines that can do even larger motors, but this is one of the most common ones out there. So I'm going to be doing this presentation on like the 2807, like the most common FPV 7-inch motor type, but there are others. So here's a 2-station winding machine. You can see there's just 2 positions, 2 fixtures. This can do about 1 piece a minute per station, 2 stations with 2 fixtures, so it can do 2 pieces per minute for this machine right here. And a good amount of the machines, like the high quality ones, the ones that DJI uses, that one runs 4 positions, 4 stations, and that one can do 4 motors a minute. And so this is what it looks like when you actually wind the copper wire onto the stator core. You can see that there are 3 leads twisted and coming off of it for basically plus minus ground. And then here is the copper wire that's wound. These are motors that are wound, and after it's wound, then essentially it just needs to have the CNC cap and magnets placed on top of it, and then electric current is applied, and that spins the motor. So after you do the winding, you can see here there's the actual assembly. This is the main structure of it. This is starting to look more like a market and consumer ready motor. You can see there's the 3 lead wires coming off of it that's bound in a sheath, and there's some electrical tape there to make it much more accessible. And you can see here's what they look like after the get their coating over it. After which, then the the shaft has to be placed into it. Magnets need to be placed on the outer shell. So this is the outer shell. This is the part that goes on top of that electronic coil stator core. So this is a CNC part here, which is connected to the stator core, as you saw here, with a shaft. And this piece has to have magnets placed on it, which is this. This is a magnet placement machine. Here is a little bit of glue to make sure that they stay in place. And once these magnets are in place, then once you apply current, that's how it's done. So this is what it looks like when you have the wound stator cores with the leads coming off of them, and you have the outer shell. This is a close-up of it. This is the outer shell with the shaft, the magnets placed in perfect position, and you have everything glued and dried, and it's tight. After which, then we need to press them together, which then creates what we know and see as a consumer motor. After which, then they go through testing, they go through vigorous quality controls, they make sure that they are working using different kind of electronic tests, surge waveform, dynamic balancing to make sure that they're stable, bearings to make sure that everything is going to work under high load, temperature testing and things like that, resistance and all that. So they're all pretty much tested right after. It's not done in samples of a few tests per batch. They're all manually tested, and then after which they get packaged up and are ready for shipping. Now, this is the perspective of the motor manufacturing out in China to be prepped for an order. But if you want to build out your own assembly line, then these are the things that you'll need to know that goes into the process of manufacturing them in-house. So this is a close-up of the winding machine. We've got a 4-station here. This is actually one of the machines that were used for Dronarnia. You can see the logo down here. And this is also the machine that is used by DJI and T-Motor. So this is a very top of the line machine for station winding machines here. Here on the right, we've got the glue machine. This essentially just, you can see there's a syringe of glue. It just places glue around the piece, the outer fixture that goes, the outer the shell that goes onto the stator core with the wound copper wire. And this is a magnet placing machine. So this is going to place the magnets perfectly evenly around that outer casing so that it can fit where there's glue, and then that will be pressed into where the stator core is. Here's the shaft pressing machine to actually press the two pieces together. Here's some electrical equipment to make sure everything gets soldered, and a few other things that are going to be needed for that process. That's a high pot. Here are the testing equipment machines. So these are dynamic balancing. We've got the potentiometers and things like that. These are all required to make sure that the equipment works after the motors are produced and stamped together with the shaft stamping machine. So these are a handful of things, and everything else will pretty much be itemized on what they need. So here's a rough estimate. This is for the 2807. Larger motors will use a different subset of equipment. It's going to be a little more, but here's a rough outline. The winding machines are for 4 stations, going to be around there, and then you need the tooling, you need the LCR testing, high pot, then the other testing equipment, so surge waveform, motor free load, and then we got a shaft press, the manuals. We got these removal machines in case things are there's extra copper, soldering, more types of soldering machines, that dynamic balancing machine to make sure that the motors are balanced. We need a bake as well, the automatic glue, magnet assembly, motor fixture, and then the laser printer. All of these things will be necessary, and it comes out to be about $100,000, give or take, for that, not including the components. And this is really key. The components are really required, especially if you want to be able to get everything and then be able to start working on it. You want to get the components as well, and so you want to get them at good wholesale rates. So we've got the cores themselves, the wiring, and things like that. And a good amount for a in-house production line build out is about 10,000 units. Or you can try it with 1,000, but you'll probably need to get more. And that's basically what things will look like. And so you can see here for one motor, you can get a motor down at raw material cost under $10. But obviously the early rounds of making it, you'll have to probably test out a few things, do some trial and error and learn. But with the training and everything, you should be able to do that. Yeah, the CNC housing is going to be expensive. You can do it yourself if you have a CNC machine, and you'll get schematics and things like that. So with our partners, they charge roughly $22,000 for training. That's on site. They showcase everything, and it's an entire process. But that's to be able to get also the entire support, all of the work instructions, jigs, the bill of materials, control plans, component drawings, everything that you basically need to be able to do this stuff. And that's on top of it. So that's a general gist of it on a rough estimate. But on a larger motor production size, which is going to be encompassing larger drones with bigger motors, with bigger wingspans and propeller sizes, then it's going to be a little more. But this is a rough guideline of what that's going to look like. This is an overview of the equipment involved, the machines involved, some of the components, and just rough pricing, just so that you have an idea. But of course, things are always going to need to be detailed out based on the quantity of components, also shipping and things like that. And there's some logistical issues now due to China not directly shipping certain things to mainland Europe, but all of that gets hashed out once we get to that stage. So that's all from me. So hopefully you found this helpful, and take this for consideration so that you can make the best decision possible. Thank you.